continue with the solutions to the quiz of March 2021. So question number 7, the question was, if you remember, you were given this information. You were told phi to the power 9 was equal to 9 to the power phi, and you were asked to find phi to the 18. This was not a difficult question at all. This was actually something from secondary school. So if this is the case, then it means what to try to do is I look at what I'm supposed to look at and look at what is given to me. I have a phi to the power 9, I have phi to the power 18. I can try to express this as something to the power 9. So let's see. So phi to the power 18, I use phi just because I wanted you to use your skill to solve it rather than remember that it's x or y. So I chose a letter that you are not very familiar with, just to make sure that you understand the principle. So if we look a bit at our power, then we can express that 2 times 9. You've learned in the past that, for example, when you did exponentials and powers, this is, for example, a to the m plus n, am on a n is a to the m minus n, a to the m, all that to the n is a to the m n. You learn this stuff in the past, so it means we can use this and move to this side. This way I can write this as phi to the power 9 all that squared, because we said this is true. So you can actually, it's also true that a to the n to the power m is the same like a to the mn. So if I do that, means if I open, I can get again 2 times 9, and that's 18. But at least I have something that looks like what was given to me. So I can replace my phi to the power 9 by 9 to the power phi. So this is 9 to the power phi, all that to the power 2. But if you look at the answers, you will see that there was no answer like this. You have to try to make sure that you simplified your answer to look like one of the possible responses. So in this case, we could just interchange. A to the mn is the same like a to the nm. So this can be written as 9 to the power 2, all that to the power phi. And 9 to the power 2 is 81. So this is 81 to the power phi. So that's why the answer was C, 81 to the power phi. So let's go to the second one. The second one is in the same direction. Both were trying to test the same skill. At least that's the idea of the quiz. We'll try to make sure that during the quiz, we'll try to test 2 or 3 skills. So you will find questions that come around that topic. So for this one here, we're also supposed to understand, for example, that the nth root of a actually means a to the power half. 1 over n. That means root a is a to the power half. If I do 2 roots, for example, cube root of root a, that means this is a to the power half, or that to the power 1/3. So just cube root is 1/3, square root is half. So that is the same thing. So this is like a to the power half times 1/3. I will apply that idea here. So here, you are supposed to use the idea of manipulating powers when you have multiplication of exponential that have the same basis, and you have to play around with their powers. So like we see here, I have delta, 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 delta. So it means this can be written in the form delta to the power 1 on 5, or that to the power 1 on 6, or that to the power 1 on 7. This can be delta to the power 1/4 to the power 1/5 to the power 1/6 times delta here to the power 1/3 to the power 1/4 to the power 1/5 times delta here to the power half. When we don't put any number, it means square root to the power 1/3 to the power 1/4. Writing this out neatly, then I will get something like, this is delta here to the power 1 on 5 times 1 on 6 times 1 on 7. We already saw that a to the power m, all that to the power n is a to the mn. So it's the same thing we are applying here. Times delta here, this is 1/4 times 1/5 times 1/6 as a power times delta here 1/3 times 1/4 times 1/5 times delta here half times 1/3 times 1/4. If you multiply this out, A on B times is A on AB, 1 on AB. So I'll just multiply the denominators. So this is delta to the 100 and 210. So the 5 times 4 is 30, 30 times 7 is 210. Times delta here, 4 times 5 is 20, times 6 is 120. Times delta here, 4 times 5 is 20, times that is 60, 1 on 60. Times delta here, 2 times 3 is 6, times 4 is 24. 5a to the m times a to the n, this is a to the m plus n. So we can actually sum all those powers. That means here this is my delta to the 1 on 210 plus 1 on 120 plus 1 on 60 plus 1 on 24. To arrange this well, if I arrange this properly, this is delta here to the 1 210 plus this has, yeah, they have an LCM here, and that's 120 here. So I would take 120. So 120 divided by 120 is 1 plus 120 divided by 6 is 2 plus 120 divided by 24 is 5. So that's 5 on 120, and that's 8 on 120, and this reduces to 1 on 210 plus 1 on 15. 8 on 120 is that. If you arrange that well, you're going to get 1 on 14. That means the 14th root of delta. That's why the answer was D, and that was the 14th root of delta. For question number 9, you ask which of the following equations has roots 2 theta, theta minus theta, where theta is a real number. So it's just the way the proportions are made. So if theta was 2, for example, it means the roots will be 4, 2, minus 2. Or if theta was 1, for example, the roots will be 2, 1, minus 1. That's just the idea. So you are given these equations here, 4 of them, and you were asked to check the roots of these equations to see which is there. Of course, the idea was to look at those equations. These are all cubic polynomials, so they are all to the power 3 maximum. That's the degree. So it means they should have 3 factors if you have to factorize them. But here, if you notice, all the first 3 terms are all the same for all of them. What is different are the constants here. That means if we get an x that happens to satisfy this equation, then when you fit x here, it should give you the opposite sign of the constant. So it should give you something like minus 45, minus 18, minus 51, or minus 54. So what I'll do is, let's take this part, only this part, because this is common, and try to guess the first few x values that can get there. Because for a cubic polynomial, you start by guessing one root, and after that, you can then use Euclidean long division to get the other ones. So let's say we take that part, x cubed minus 6x squared minus 9x. On this now, we're trying to look for the first factor or the first root that we will use and then solve this equation. So if we say we try x, we have to try x1 minus 1, x2 minus 2, x3 minus 3, and so forth. Until we get 1, then that's fine. Then we can get the others by long division. So let's try x equal to 1. If x is equal to 1, I put 1 here, then I get 1 cubed minus 6 times 1 minus 9 times 1. And clearly this is 1 minus 6 minus 9. That is nowhere around any of those numbers that we see here. So x equal to minus 1. Get minus 1 cubed minus 6 times minus 1 minus 9 times minus 1. Minus 1 cubed is minus 1. This is plus 6, that's minus 5. And if you take that with this, also nowhere any of these numbers. So 1 and minus 1 was not possible. So let's go now to the next one. X equal to 2. This is 2 cubed minus 6 times 2 squared minus 9 times 2. If you evaluate that, this is 8 here. 2 squared is 4 times that, that's minus 24. And this is minus 18. If you arrange this, it's also nowhere. This is minus 34. No. So 2 was not possible. So minus 2 here, cube, minus 6 times minus 2 squared, minus 9 times minus 2. Minus 2 cube is minus 8. Minus 6 times this squared, this is 4, because minus 2 squared is 4. That's minus 24. Minus 2 times, minus 9 times minus 2 is 18. If you arrange this, you get minus 14, which was also nowhere. So we can try x equal to 3. Try, that is 3 cube minus 6 times 3 squared minus 9 times 3. 3 cube is 27. 3 squared is 9 times minus 6, that's minus 54. 3 times minus 9 is minus 27. And you see clearly here, this is minus 54. So 3 is going to this one. So normally you should just know that that is the case. But it's important to check to see that the roots have at least these two situations. So x is equal to minus 3. If I try that, then I get minus 3 cubed minus 6 times minus 3 squared minus 9 times minus 3. Minus 3 cubed is minus 27. Minus 3 squared is 9 times, that is minus 54. Minus 3 times minus 9 times minus 3 is plus 27. And this is minus 54 again. So it means we already saw two roots. X here equal to 3, x equal to minus 3. From these two roots, you can actually see that you have two factors. Now with the factors, you can come here to get the last factor. And that last factor is just going to be 2 theta. So the last one will be x equal to 6. If you do that, then you will see that you have the form 2 times theta minus theta, where theta then is 3. So the answer for this was D. You didn't require to go up to this step to know that D was the answer. I'm just doing this for completeness.